So I will try to keep on track on this topic to focus on the challenge. Well, there are many challenges in using AI, and there are some that are relatively unique to AI in defense. And I think the thing I would like to focus on in my brief intervention today is really the challenge that we have to make sure that decisions that are being made by artificial intelligence are in fact acceptable. And one of the challenges that we often face is that the situations that we observe, be they in combat, or be they in monitoring activities, or be they in preparing for counter measures if we come under attack, they happen with a relatively low frequency in reality, which means that we are building systems typically for situations or for occasions that we may not even have observed yet. So we're building systems on the eventuality that somebody is going to launch a missile at us, that somebody is going to attack us. And we build systems that are then meant to, well, we can always have a longer discussion about that later, but that are basically meant to increase both the speed with which we can respond to such activities and the quality of the response that we give. So I hope you can see this example of one of the challenges that that we have. We know from the international scene. How do we somehow detect somebody launching a missile? We have a whole decision chain that needs to be fulfilled. We have only a few observations of such missiles being launched, which means that we have to generate sufficient data from other means, or set up sufficient rules. That means that we can first identify that something out of the ordinary is taking place, classify it as something that is a threat or a potential threat, present this to somebody who can make a competent decision whether or not this is in fact a threat, an exercise, or something else, and then present this in a way that a decision maker can in fact make an appropriate decision of what should be the response. Now, this is a good example because we see it in a lot of situations. It could be countermeasures for cyber attacks. It could be countermeasures for physical attacks on infrastructure. We face within the AI community the challenge that it is relatively, I would not say trivial, but it is not the hardest part. Is not necessarily determining that something extraordinary or different is taking place. It may even be relatively straightforward to say that it is a threatening situation. The challenge is in a simple way to condense this into appropriate decisions and present these to a decision maker in a way where the decision maker is capable of making an informed decision. So the biggest challenge that I've seen so far has been that we do not want the human in the loop to be simply a machine himself or herself who's simply saying, the computer presented me with an alternative. Should I shoot this missile down? Yes, no. We want the decision maker to be presented with credible alternatives where the decision maker can in fact say, okay, there's a threat. Is this a threat I should respond to? Yes. What is the appropriate response? And not just one thing. Now, this is highly complicated, and it's one of the things that I've had a lot of pleasure working with in different situations where I can give you examples of where we developed algorithms that gave optimal results to certain situations, where the end users came politely back and said, they may be optimal, but they're not intuitive for our users, so they will not trust to release this plan for execution. So in that situation, we are faced really with this highly interactive environment where we want the AI to do some things, but we do not want the human just to sit and verify. We want the human to use the human capacity for acting outside of what's been seen before, because I think this is the biggest thing where AI has a challenge. AI is basically able to react to things that it has been trained or it has worked on before. The human is able to extrapolate from previous experience and make decisions. So this is really the challenge that we have in this connection, to make sure that we just do not turn into a delay on a decision process, but we actually get the human's expertise into the decision making in such a way that AI, together with the human, end up with a better solution than either would have arrived at alone. Now, before my 7 minutes are up, I would like to say just a brief thing about what we are doing from the side of the university. And I can highlight a educational program that we're running now with plus 30 partners in Europe, called Assets, which is the Skills Alliance for among others, AI educations for the defense industry in Europe. So we have recognized, and the European Union has recognized, that this is not your regular AI toolbox that needs to come into play when we're dealing with these types of activities or scenarios. We have recognized that we have to do something different. And as an academic, I'm of course very happy for that, because this is how I ensure that what I do has relevance. And I may want to, before my time is completely up, to say I'm not one of these pessimists who thinks that we will come to these scenarios of AI running rampant and making horrible decisions. I hope we are together smart enough to exactly figure out how we achieve synergy between the capabilities of AI and the abilities of humans, rather than to take the worst of both. So this is a joint challenge that we have, but I'm also confident from my interactions with people in the industry that this is actually the way that we're going. So from that perspective, I'm an optimist, not a pessimist, but we really have to consider if we, at the point we are in now in time, have developed our toolbox and maybe also develop the users or their understanding of the technology.
You're
Yeah. Sorry? Okay. Thank you. So, this was just my last point. Was this that? Can you hear me? I'm sorry.
Okay, thank you, Peter. We'll come back to you later again, I'm sure. Now I have the pleasure to introduce Andrea Gilli, who is a senior researcher at NATO Defense College, where he works on issues related to technological change and military innovation. In the past, Dr. Gilli has been visiting and postdoctoral fellow at Johns Hopkins University and Columbia University, as well as at Stanford University and Harvard University. His researches have been published in the most important academic journals on security issues, such as International Security, Security Studies, and Journals of Strategic Studies. He's received several awards for his work, and he holds a BA in Politics and Economics from the University of Turin, a Master of Science in International Relations from the London School of Economics and Political Science, and a PhD in Social and Political Science from the European University Institute. Andrea, Dr. Gilli, over to you.
Thank you very much. Good afternoon. Thank you to the NATO Defense College Foundation for this kind invitation. I just want to add a couple of things which are related to the previous presentation. We generally see, or are generally told that artificial intelligence is a dual-use commercial technology, can be easily exploited, and for that reason is prone to disruption. What it means is that there is significant concerns, exactly as Peter was saying, that it could go rampant. So I want to provide a more reassuring view here with you. So first of all, what is AI? We can understand AI basically as the product of three different dynamics: growth in computing power, new software capabilities, deep neural networks and machine learning, and the explosion of data we have been observing over the past decade or so. Now, exactly, that's a slide about the growth of data. So Andrew Ngo, which was at Stanford but also part of Google AI capabilities, claims that data is the new oil, trying to suggest that it will unleash an enormous revolution. But exactly like oil, well, to exploit AI, we need drilling capabilities, like sensors. We need refineries, which is data scientists, as well as data pipelines. Like we move oil through pipelines, but at the same time we need to move data through data pipelines. Now, what is important in my view is that each of these three components, which we could call the AI triad, poses significant challenges. So think about processors. Very few companies around the world are able to produce advanced semiconductors, for instance. Same about algorithms. Laszlo Bloch, who was the head of HR at Google, was saying that one top engineer equals 300 good engineers. So if you want to write a good algorithm, you need to have really the top of the cream if you are in a high-tech competition. Same about data, that data are everywhere, but to clean data, exactly like refining oil, is a significant challenge. Now, but there is more, because once even you have the triad set together, well, exactly like oil 100 years ago, you need highways, you need cars and fuel engines to exploit the AI revolution. And this requires time, requires investments, requires personnel. For instance, there is the important debate in Europe about 5G communications. Well, we are developing the AI part, but without 5G communications, it will be very hard to exploit what AI can do. But setting up the entire communication infrastructure with 5G will be extremely challenging, will be difficult, will be expensive, it will take time. Same about quantum computing, because we see the Moore's law is coming to an end. So the growth in processors' power is slightly stopping because of physical limits. So the future is probably quantum, but quantum poses challenges which can be, to be addressed, will need more reliance on communication, and so on and so forth. So what I want to suggest is that exploiting AI will be only from a physical perspective difficult, but there is also an important human or social dimension. I like Peter's final point about prevent AI to do a lot of damage. Now, if we look at the 19th century, we saw that human beings, sadly so, were able to do a lot of terrible things without being driven by technology. We're human beings. So the social part, the human part of technology is really key, and this applies for the bad and for the good and for the bad. And on the good part, we need new type of social organizations. For instance, when electricity was introduced to production plants, well, companies need to rethink themselves, to adopt different organizational setup. The same will apply with artificial intelligence, which entails, for instance, changing recruitment patterns, retaining procedures, as well as training and education. So I work at the NATO Defense College. We're kind of partners, honored partners of the NATO Defense College Foundation, and we do strategic level education. Think about leadership. As was said, leaders until now are used to take decisions based on their own experience. In the future, if you want to exploit artificial intelligence, leaders will have to think in a more probabilistic mindset. And this requires is a cognitive challenge that not everybody will be able to do. And so this requires strategic level education to permit people to switch mentally the gears and face the new challenges. I have 2 minutes, but I just want to make a final point. So if you look at the ensigns of any military branch, you see airplanes or you see warships and so forth. It's unlikely that any military service will have an algorithm as an ensign in the near future. But this is good and bad. It's good because it means that all military services may benefit from AI. But it's also bad because it may mean, when we think from a military perspective, that no single military service has a strong interest in the technology. So in my view, what would be needed at a national level as well as the NATO level is probably an AI champion, like an organization, an office, a unit, which really pushes through AI issues and tries to basically support and provide help to the different branches, the different organizations. Think about running exercises in which you try, every time you do a war game or a simulation or as an exercise, gather data to see how much you can exploit new technologies. Or think about how procurement is changing, because with AI there is a switch, so the line between research and product is getting blurred. So you have to rethink the way you procure weapon systems. And so an office which basically approaches the military branches trying to help in this transition may be needed. I'm very happy that I'm ahead of time, but I can close here. And so thank you for the attention and look forward for the Q&A later on.
Might save something for for your next speaker, for your colleague. Our next speaker is Roberto Manca, and he is an Italian Air Force officer working at the Air Force Staff in Rome. He graduated from the University of Naples in computer science engineering, and before being posted to the Air Force Staff, he served in the Italian Air Force Flight Test Wing, where he covered many roles in the aircraft systems development and flight test on over 100 projects. His main areas of interest have been avionic software, human-machine interfaces, modeling and simulation, sensors, equipment, and data link integration, certification and airworthiness on over 30 aircraft. He also holds a Master in International Military Strategic Studies, a Master in Business Administration, and a Master of Science in Scientific Computation. Roberto, the floor is yours. Thank you.
Thank you very much. Thank you, and thank you for. I'm very happy for being here today. Well, I'm very happy of what Andrea said, but I think that the point is exactly where it laid on. I mean, we have two main issues if you think of a capability gap, which is speed and size. Well, the speed is the speed of the decision-making process which we are now used to in the civilian world, which is required to in the military world. I'd say hypersonic speed. If you think of the threat we are going to face in the near future. And also the size of the data that were just mentioned. We need help in translating those data and information. And so how do we make sense of those computer-generated data? The answer has always been straightforward, with other computers. Now AI came into fashion lately just because of the enablers that Andrea mentioned earlier on. I mean, the speed of the processor and the memories that are now available, the triad, as it called them. But the point is that the application in the civilian world are very promising, and we're start to exploring them in the military ones. So if you think of ISR, where we can find object detection or computer vision or tracking or identification, or the cyber world with the attack and defense, or the infobes, you certainly have heard of deepfakes. And what they can do, but also logistics and procurement, as Andrea just mentioned. The point is that all those are just techniques, enabler, things that were already done but now are becoming possible. And militaries are very keen on what can be the applications in their world of this, especially when you couple them with collateral topic, which is the one of autonomy. which is not the same, but is certainly collateral of whether actually you can have autonomous weapon systems. So weapon systems that can autonomously detect targets, and we start thinking, we've seen there is a huge debate on this, also engaging a target. There has been also experimentation in the past. It's not really a new concept. There is just now the feeling that it's becoming possible, and people start to see that that can have a different and several effects on stability and on the traditional equilibrium that and balances that we had between the states. And furthermore, when you think of it, that not all the states and all the actors may share the same views that were just mentioned in the introduction on the legal and ethical implication of the use of autonomous systems, then you'll see that the balances may be altered by this, and basically by an increased speed of decision, which is good and bad. The bad thing is that the increased speed of decision may increase the likelihood of inadvertent or so escalation, because maybe an autonomous system is not that good at interpreting signaling as a human being will be. But and also we just mentioned on the other side, the swarming capability, that is basically lots of relatively cheap autonomous systems that can accomplish a task without being singly directed to do so. So basically, what I really want to underline is that there is really a pressure now for government and militaries and industry around the world to try to translate those civilian benefits we've seen. We are all used to having at our fingertips on our phones the benefits of artificial intelligence. And though I agree that it's not that easy to translate them straightforwardly into the military world, well, that's true for the data, but if we think of and take into account what are the constraints we have, the bias in the data you mentioned, and or the fact that Peter before talked about briefly on the explainability of how the algorithm has decided to present a course of action. Well, those are the exact things that are under scrutiny now for having a ever bigger role of artificial intelligence in our weapon system, just because we expect them to present with several course of actions which a military commander can select and go for once it's in line with his objectives. So, to come to a conclusion, yes, to the questions before, we need to go for that. We are going for that. There is an increasing demand for that kind of technologies. We've been there before. We hope that now we got the enough processing power and memories to finally win the AI challenge and overcome what was called once the AI winter, because we've been there in the past. And furthermore, that will enable to sit on those tables where new ways of being on the battlefield will be discussed, but will be there with a more knowingly approach, knowing what we can do and what we are not thinking of doing, and we won't like for other people doing. So thank you very much, and looking forward for afterwards.
Thank you, Dr. Manca. Thank you for your presentation. And now I turn to Stéphane Brusseneau, who is a senior expert in artificial intelligence and data analytics at the Airbus Defence and Space at Elancourt in France. For the last 30 years, he has actively contributed to the development of innovative solutions for the benefit of the Connected Intelligence Division. He has been involved on advanced technology demonstrators for the French Ministers of Defense and NATO Industrial Advisory Group on Big Data and Artificial Intelligence. He has also coordinated or participated to several EU research projects and, among others, has been appointed as a member of the high-level expert group on artificial intelligence set up by DG Connect, and as a member of the cybersecurity AI expert group set by the European Union Cybersecurity Agency. He is an active member of the French Association for Artificial Intelligence and the organizer of different conferences on the topic. Mr. Brusseneau, the floor is yours.
Thank you. Thank you to the organizers for inviting me today to the Game Changer 2020 conference. So yes, I was one of the 52 experts appointed by DG Connect, by the European Commission, to talk about or brainstorm about AI and more especially trust for AI. AI is a technology. It's not bad or good. It's a use we do that will be considered good or bad. And the European Commission decided that we need to develop and use AI techniques, and so that it is trustworthy. You may be aware of a document that have been produced by the high-level expert group on AI. So there is the ethical guidelines. There's been another document, policies and recommendations. And finally, ALTAI. ALTAI is the assessment list for trustworthy AI that has been developed to self-assess an AI system or an AI component that is being developed, and to check whether or not it will satisfy all the recommendations so that it can be considered or conform to considered as a trustworthy AI system. And so this group came to an end of June, and within Airbus we decided to continue the work that has been done inside this group. And we've decided to experiment with ALTAI. So ALTAI is a 34-page document, and it's organized along 7 key requirements. The 7 key requirements that are in the ethics guidelines. So there is a human agency and oversight, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination and fairness, societal and environmental well-being, and accountability. And the idea was to experiment with a self-assessment technique approach on FCAS. So FCAS, the Future Combat Air System that Airbus is being part of. And basically what we did was to ask ourselves whether or not ALTAI, which has not been specifically developed for the use of AI in military or defense applications. So we wanted to ask ourselves whether it could fit in a system like FCAS, or if it could be useful when we develop AI component to be used in FCAS. So I am not going to develop all the use cases that could be in FCAS, but I just want to illustrate what the ALTAI methodology is about. So just to take as an example this requirement, one of the requirements, the traceability. In ALTAI, there is a number of questions that you have to ask yourself to check whether or not your system will be traceable. You are invited to ask yourself what are the measures that you put in place to continuously assess the quality of the input data that goes into the AI system. Because it is one thing to have an AI system, but if your AI system only work with perfect data, then in operational condition it will not work. And if your system, your AI system fail, you need to understand why it failed. I'm not saying failing in operational situation, but during testing. So you need to be able to assess the quality of input data. And in order to do that, you need to collect, you need to log. Same thing, again, it's a question from the Altai methodology. What measures do you have in your AI system to trace back which input data was used by the AI system? Not only you need to assess the quality of input data, but you also need to understand which input data were used by the AI system to make a certain decision. Then you need also to ask yourself and especially to log which AI model are using a machine learning AI system, or if you are using a rule-based system, if you are using AI symbolic AI, which rules led to the decision or recommendation of the AI system. And we can also think about the operator deciding to turn off some of the AI system. So we need to understand all of that in order to be able to understand what happened. And we need also to be able to assess the quality of the outputs of the AI system. So in order to do that, we need to record everything. And the AI system may give the correct decision, but still it needs to be communicated effectively to the operator. And if for some reason, if the operator, if you are in a stress situation, you may not see correctly the decision. You may have noise that will prevent you from understanding the situation. So this is the importance of traceability. There are also in Altai all the list of questions. I do not have the time to go through all of them. Of course, explainability is an important issue. And the question we have to ask ourselves is who will be taken for responsible when the system fails. And it is important to have the man in the loop, but as some senior research scientists at Google mentioned, so Madeleine Claire-Ehrlich, we don't want to put the man in the loop just to blame the human in the end. And that will be my conclusion.
Thank you, Stefan, and thank you all the panelists for really outstanding presentations, and they have, with their insightful remarks, they have opened really a space of curiosity, questions, and reflections that have been already taken up by the public. And in fact, I have already some questions from the public, and following the order of the speakers, I would like to ask to Dr. Nielsen the following question that we just received. AI will quickly be also available for the shady side of the private sector, like organized crime, terrorists, private military companies. What do you foresee? What international agreements should be devised? How international agreements should be devised? Is there any room for international cooperation on these topics?
See, that it's always nice to have a good question. Let's see if I can deliver a good answer. I think that there are so many things now, especially things within this domain, where borders become very blurry. And that's where national states have to be careful with responses, right? Because the moment we respond automatically to a threat, it escalates. I think, I cannot remember which of our colleagues here in the panel pointed this out, but autonomous systems really have an ability to escalate a situation which could escalate on the other side as well. So the best way is, of course, to make sure that we could internationally agree on what are proper responses to certain situations, so that we avoid this escalation. So if somebody attacks infrastructure or companies in a particular way, we know what is the appropriate response, and we know that if we respond like that, there is an acceptance that that was an appropriate response. Because right now it's a little bit Wild West, so that it's unregulated to the extent that we are all worried that we can take it one step too far. So I think that would be, I think there's room, but I think it's also going to be somewhat of order of magnitude worse to regulate than for conventional weapons, because it's difficult to count. It's maybe also difficult to imagine how these weapons of or these techniques can be used for attacks in advance. We may be, the list is not, it's difficult to make an exhaustive list of what could actually happen. So that would be my answer to this question.
It is complicated if you think that there is still yet no agreed definition of armed attack and the difficulty in attribution. Then again, it opens a Pandora box of implications and questions. But thank you for that. And I now turn to Dr. Gilli. In fact, this is what I was also asking myself when you mentioned the AI champion, and the natural question comes: is there a role for NATO with respect to AI and regarding also the agenda for 2030?
Well, thank you. That's an important question. So I think there are two things to be said. The first is that NATO as an alliance has been working directly or indirectly on artificial intelligence for quite some time. So, for instance, CMRE, Center for Maritime Research and Experimentation, which is based here in Italy, in La Spezia, has been working on big data applied to submarine and anti-submarine warfare for several years. So, Allied Command Transformation in Norfolk, which is one of two head commands within NATO, has been working on issues related to artificial intelligence for several years. There is the Joint Lessons Learned Center in Lisbon, who has, for instance, run a test with big data during the Trident Juncture NATO exercise in 2018. So NATO has been working already on those issues, which are obviously on radar because they're important, and many stakeholders have seen them coming. However, we are at a phase where some decisions could or should be made, and NATO is public information, has been working in NATO HQ on artificial intelligence, and there could be an AI strategy in 2021, which is related to the NATO 2030 agenda. So allies are discussing or trying to see where trying to find consensus on several issues, but there is room for the alliance to play a key role. For instance, Stefan was mentioning the high-level group within the European Union on ethics. My personal view would be that NATO should basically build on what the European Union has already been doing with respect to ethics, because these are principles which are highly agreeable within NATO and European democracies, which are consistent with our values, and so NATO could start from there and have its own ethical principles when it comes to artificial intelligence. Let me give an example. Roberto was mentioning explainability. So one key value which NATO allies could agree on is that we develop algorithms which are explainable. So we know what they do. We know how a certain decision, a certain output was reached. That's one example. What I think about with NATO, I mean, there are several other aspects. For instance, standardization, which has historically been a core task, a core strength of NATO, and standards are going to become important because that's the way to translate ethical principles into technology. That's another area. But there are some others I just want to mention. One, and it's training, education. For instance, all countries around the world are struggling with attracting and retaining AI talent. So the pool of talent, of human capital, is not big enough for everyone. So there's going to be competition within countries. And obviously, this means that if ally A attracts more talent, ally B will have less. So this competition is, in a way, it's lose-lose. I mean, it's either you win or you lose. So the alliance could try to set up some structure, some initiatives to increase the pool of talent, while also trying to pool it. So to make sure that it is redeployable in different ways to different allies when they need. That's why I was mentioning the AI champion. So an institution which starts developing some ideas, some procedures about, for instance, reforming procurement, and is able to share them among allies. I'm happy to talk further, but I don't want to monopolize the discussion.
Sure, thank you very much. I have a question also for Mr. Manca. How vulnerable is the man-in-the-loop component in an AI-supported system, according to your experience and knowledge?
Well, the point is actually that the man-in-the-loop is, as we discussed in this panel today, is seen actually to be the strong point, as not the weak point. The weak part comes into how you decide to integrate that man in the decision process, or even if you want to have a man in the decision process, because that is not really something that is being agreed upon across the world. Not everyone shares the concern that Dr. Gilli just mentioned. I mean, we're seeing now that we are starting to lay out at UN or EU level principle for ethics in AI use. Well, that's just a part of the world. Not everyone is going to is agreeing on those principles, just as not everyone agrees on the principles of warfare. So yeah, the real question is how. It's not really probably if the man is the weak part in the process, but what are we going to? What are we expecting to have? Where do we want to put them in the what we call in the military world the OODA loop? What do we want the man to be on top of AI alternatives, or do we want them just to have some decision support and then having them to decide? Or because we already seen in the past, also in Western country, do we just want to launch a system and then have them to behave how it will end up autonomously? This is probably the real question.
Thank you very much. I will now ask a question to Stéphane, if he is there. Yes. You have been involved in the industrial defense sector, and what, according to your opinion, would be the right balance between private and public funding in military AI applications? Are you?
Yes. So when I was listening to the other panelists, so there was this reference to the high-level expert group on AI and the work we did on ethics. There are also a work that has been done on policies and recommendation, and in this policy and recommendation, there are a recommendation for keeping talents, for setting up big AI research centers, and many other recommendations. So public funding is important, and for instance, the European Commission recently published this call for proposal, the EDIDP call for proposal, and there were a specific topic on artificial intelligence, and it will encourage companies and academic partners and SMEs to work together and propose a solution that will be developed within the EDIDP framework, and then later on in the under the EDF, the European Defence Fund umbrella. I could think of a similar approaches at larger level, and private funding, of course, is important for every industry partner, SME startup to develop their own capability. For instance, in France, we are working with one startup, with the only European startup that has developed formal validation of machine learning models. So both are important, but public funding is important to invite cooperation, coordination, and I think that is key to develop secure and trustworthy solutions.
Thank you. And before I go back to the questions from the public, while Peter was speaking, he and other panelists also highlighted the very important relation and necessary relation between the machine and the human decision maker. So that's from what I have taken away from this first round of interventions and questions is one of the key elements. Now, in concrete example, Peter, what is your experience showing you? I mean, how's the testing going? Where would is there anything in particular that you would advise to look at? Some specific moments or experiences that you have to share with us, that you can share with us?
I'm trying to think of an example that I can share, but I can maybe generalize across a number of examples that we've had. It takes thousands of examples of success to get people to trust the system. It takes one failure to make them believe it doesn't work. And this is a challenge that we see with AI because they don't understand the technology in itself. Even if it is explainable, they don't understand necessarily how the chain works. They have to have confidence that the results they get are the right ones. Which means that it has to look like what they would expect to see if they had done the job themselves. And this is a challenge that I think we need to work on jointly to solve. What we have noticed, and I share your observation, I found it interesting that we were all more worried about the interaction between humans and technology rather than the technology or the human by themselves. And I think this is something where we are not really there yet. I know that there has been some. I know NATO has launched some innovation challenges. It's a topic that is gaining some attention. So the best way, I think, is extensive simulation, extensive training, and building confidence at the user's side that they are being presented with the right alternatives, the proper responses, the proper classifications, and ensuring that they have confidence that when it matters and they have to push a button, they are actually doing the right thing. Instead of, as Stefan politely pointed out, just being there to take the blame.
Thank you, Peter. And while we get there, what are the concrete risks for escalation? I mean, can you share some, again, concrete example, even if it's abstract ones?
Yeah, well, thank you. Well, actually, well, the abstract is the right word probably because the field being so new, most of those will be basically speculative. Dr. Gilli already mentioned the difficulties in translating technology, civilian technology in the military one. But we mentioned earlier that artificial intelligence can be integrated into decision support system, the one that has been just mentioned by Dr. Nielsen. And well, in that case, for example, it depends on the principle we discussed before, whether how much authority we want to delegate to the system. And we are thinking and talking about the human-to-machine interaction. But what about the uncharted world of machine-to-machine interaction? We've already seen this kind of failure in the stock market, where you've seen that several artificial intelligence, well, algorithms, were competing to each other in very high velocity transactions, leading to the fall of stock market without any connection to what was the real world, what was happening in the real world. They were just interpreting a signal, but they were artificial in themselves, so that basically they created a war against themselves without proper explanations in the real world. Or also the idea of having artificial intelligence in helping to track and detect and identify objects. We've seen on the news that artificial intelligence aided drones basically were used in China to help identify jaywalkers, the people that were crossing on the street without respecting the signals. Think of this if you use the same technology and try to find and locate command and control centers or mobile launchers, which in fact will have the effect of denying a second strike capability. Well, it's fiction by now. This technology doesn't exist yet, but in theory that could actually, on the other side, raise the level of alert for those weapons. And if you think that it's not really needed that you actually have the technology, you just need to have your adversary to think that you are in that position to make yourself nervous and thinking of actually pull the trigger in a use them or lose them situation. Or also in conventional warfare, where you may have heard of swarms. Well, those are kind of teeny or rather inexpensive, or at least they should be drones. But put together, they can have a massive effect on much more technology advanced weapons systems, aircraft. So you don't need to be the nation with the most powerful weapon system if you can have those horde of smaller but effective small drones, and that can tip the balance. Well, actually, as I told you at the beginning, those are all speculations at the moment, because many nations are trying to experiment on how can then push forward on these paths. But since everyone is looking at what the others are doing, well, that needs to be taken into account, and probably will be it's a good topic in the future studies on in NATO on how that will influence future of warfare.
Thank you very much. Dr. Gigli, I have a question for you coming from the public. Would you elaborate more on the role of AI also in intelligence and counterterrorism?
Okay, that's not exactly my field, but what we know are two different issues. So, artificial intelligence is generally a dual-use technology which can be redeployed for several tasks. So we can use it for X-rays and seeing whether oncologists or radiologists actually miss some health issues, and we can similarly redeploy when it comes to communications. We can redeploy for tracking individuals, and there's definitely a room for using machine learning techniques for tracking and fighting terrorism. The project Maven in the US ultimately was doing something like that. It was non-kinetic. So it was not about the use of force, but it was about using machine learning algorithms to oversee a huge amount of data and basically track individuals which were suspected or in this way became suspected of supporting terrorism. Then ultimately Google, there was a big protest within Google, and the project kind of collapsed in the US. So that's one aspect. We could exploit same technologies in a way like our Gmail. All of us who have Gmail see that Gmail in a way organizes our mailbox, and ultimately similar software can be used to track communications among individuals and eventually identify those who could be responsible for terrorism. But definitely there are some issues which again are ethical, political, which is about surveillance in our democracies. Now, what's the trade-off? We want that everybody is totally and constantly controlled in order to have perfect counterterrorism. I mean, it's about a trade-off, and I'm not saying which is better, but we may have our own views, and definitely something which I guess in a democracy should be discussed in Parliament with an open debate so that people understand exactly what is going on. There is, in other cases, for instance, I mean, some countries, the key is how you define terrorism and who is the terrorist. So some countries may use facial recognition software to track terrorists or what we may call just minorities or political opponents. And again, that's a room. And so one of the first questions was about how the connection between the use of AI by terrorists. So, and what we could do. I think, for instance, democracies, NATO allies, European members could, for instance, one area where they could work together is say, we work so that our own technologies, our own companies do not support kind of missions which go against our ethical political values. So you work together to say we're not going to supply the technology to the countries who are going to use facial recognition technology to suppress minorities. We are going also to make sure that our companies do not develop, so we put kind of controls on the software, the equipment they develop, so they cannot be repurposed for that task. I'm not saying it's easy, I'm not saying it's going to happen tomorrow, but there's some issues where, in general, there's room for international cooperation. But still, AI can be used effectively to try to fight terrorism, but we also have to be aware of the counterpart, which I believe is important.
The more we all speak again and the more we see the need for international cooperation, it's a bit like in the past when the nuclear age was dawning, there was a need of increased cooperation and shared definitions and information sharing, which was politically very difficult. Now, this brings me to a reflection that I would like to share with the panelists and see if, and a question that to all of you, and see if you have some ideas about that. At that time, scientists made it to establish forms of cooperation that were a bit conducive in creating a good environment to talk about the topics that were difficult. Now, what is the scientific community doing at this time towards, in relation with AI? Do you see any possible avenue of larger cooperation between different worlds, different visions? Is an avenue that can be suggested? Governments seem to be in difficulty in finding a shared way. What is a possible potential role of the scientific community? I don't know if and who wants to take it.
Well, I may take the opportunity to launch a stone in the pond. Well, the question is very much actual because the scientific community is actually very worried about the possible implication, and that comes to the dual nature of this, which is basically a technology. It's not a product, it's a technology. So basically, as we have come to understand by now, you can use it for bad or for good, but because of this, it's very difficult to control. The same image detection algorithm can be used to find cancer in an image, or to find a dissident into the woods. Well, it's very difficult to establish a control. So in principle, the scientific community can agree on ethical principle and on how that specific algorithm can be used. But I don't think that it will be a definite answer. We just mentioned, Dr. Gilli did it, that Google scientists refused to work for United States Department of Defense sponsored project. But that didn't stop other companies doing that. It didn't stop Google to be present in countries where that debate is shifted on other techniques, which are not that specific project. So you see, even the same scientists, everyone wants to do it for the good of humanity, but it's very difficult to control and to be effective in controlling how this technology will be implemented in the future, and that will very much depend on the cooperation, as you mentioned, with government and politics, because of the regulatory nature of what we can do with that technology.
Thank you very much. I have a question for Stéphane Bruneseau from the public, and that is, at what stage of maturation are AI-based predictive models?
Yes, so it depends on the domains, but for instance, in Airbus, we are developing machine learning models to process satellite imagery. And with these models, we can automatically analyze the satellite imagery, and for instance, to count objects such as aircraft that are near an airport, or count a pedestrian, or we on a different domain, which is not a military one, we use these AI models for precision agriculture. But to come back to military application, the same techniques are being used for automatically analyzing radar images. On a different kind of application, we use machine learning algorithms, and especially all these anomaly detections techniques for instance, for maritime surveillance. If you have an operator in charge of monitoring a large zone using different equipment, sonars and so on, he cannot monitor all the plots, and so then you have the assistance of an AI system that will be able to automatically, for instance, spot two boats that are coming close to one to each other, and it might be the signal that there are some illegal trafficking or things like that. So yes, these models are mature and can be used operationally.
Thank you. Again, while you were all speaking, it occurred to me to think that most of you said we're not there yet. And so we have also to consider the development of AI as a process that is not happening in a vacuum still. So there are debates and tendency in the technological development that go towards decoupling of bifurcations. So my question that I again throw to all of you is, since we have to develop AI and new technologies, how would this be influenced, according to your opinion, to the tendencies to decoupling supply chains and bifurcation that we are observing at the moment? Would it be beneficial, paradoxically, or to the detriment of the development of an AI that is beneficial to all, in all fields? Anybody who wants to comment on this question? Peter.
Yeah, I can try, because I think this is really, it's a good observation, and it's one of those where there is probably not a black and white answer. But what we can say is that previously we were always talking about technologies and methods moving primarily from defense and aerospace into civilian life. AI is really one of the ones where most of the dialogue I hear together with the partners I work with is how to take what is developing in civilian applications and see if they are applicable or suitable for defense applications. Now, this is challenging for two reasons. The first reason is several of the panelists have mentioned this. There's the matter of talent. RAND Corporation did a study on the attractiveness of the defense industry, and this is an area where we must admit that we heard the example with Google employees who did not want. There is really a problem maybe of attracting the right talent mass for this. But the second thing is that there are some technological challenges in terms of data access, explainability, and other aspects that you find in very few businesses. Which means that even though the civilian applications of AI are really exploding, I would question whether or not we are at the same speed developing or closing the specific gaps that we see. So I think that we are in need of a two-string strategy. One is to make sure that we are capable of importing the technology developments that are coming from all types of industries. And the second one is to ensure that the specificities of the defense sector or the application of this technology, that we're developing the technology ourselves to be capable of closing that. And then back to this is a decoupled strategy. Rather not. I think this is exactly where we need strong organizations, for instance, NATO, to take a very active in ensuring actually coordinating this and closing the relevant gaps together. Because otherwise we are really running the risk that these gaps remain unclosed, and then we will really have the problem of is it trustworthy, is it explainable, are we really exploiting it enough? So I think this is a challenge that we have to take serious. And it requires a coordinated effort that I think most single countries will find very difficult to manage. And you then have the problem that AI is now becoming integrated in so many things that your whole chain activities or products or have to somehow be able to understand its counterparts or its integration surfaces. And that is a challenge if we close down and try to do it individually. So I think this is it's a real hot topic.
And I understand, I totally agree about the role of NATO, but that leads me to think about, since we're all European here, about the role of the EU and in relation also with the cooperation with NATO. Where are we according to you? I mean, what are the chances, the difficulties, any shares that you want, any thoughts you would like to share? Sure.
So it's kind of related. It is so. So private companies are doing the bulk of the research in AI, and that's great. The problem is that they do the research that serves them, logically. This means that when we think about defense, when we think more broadly about the missions that governments have to fulfill, the trajectory of the technology is not perfectly overlapping with the interests of governments for their purposes as well as of defense. So there's an important role to play for public authorities to kind of give incentives as well as funding so that the research is done in AI is less narrow, is less short-term, is also less environmentally and technologically unsustainable. I mentioned in my presentation the aspect of Moore's Law. Moore's Law is about the growth in the power of processors over the past 50 years or so. The problem is that the Moore's Law is kind of flattening. The big explosion of machine learning was around 10 years ago when there was a transition, so parallel processing semiconductors were used, but we cannot keep moving in the direction of increasing performance and decreasing size. This is going to be very, very hard, and so there's a big, there's a room for governments to fund research that goes in the direction is more sustainable. I just give you an example. So AlphaGo, when it was run, it costed like 100 million or something like that to train the algorithm. The data I'm providing maybe is inaccurate, but what I'm going to say is that we cannot go with a technology that basically burns so much energy, pollutes so much in the future. We need to gear, and I think there's a role of government, and the European Union as funding on research, which I believe could be used in that direction. I think that the recovery plan, in a way, goes already that way.
Okay. Any other panelists would like to come in on this one, on the EU? If not, I have other questions from the public, one of which is about the challenges, if any, that AI poses in terms of industrial secrets protection.
Well, I may take that. We already talked about the exportability of techniques from one domain to another, and I think in this this is not a new topic. I mean, the protection of the most efficient algorithm in a domain has always been connected with the intellectual property rights in industry. But the reality is basically that in these techniques, the basic is that there is no one size fits all. I mean, we just mentioned AlphaGo, we have Siri or Cortana or things like this. Those are, since basically in artificial intelligence, the entire space of those algorithms is dictated by data. Well, the point is that it's not just the algorithm. There is no really secret. There is an abundance of literature on AI algorithm since the 50s. The point is on the data and on how you have the right data to have the right effect when you need it, and you can trust it. That's the real question. Not the others are basically problems we already face that we can face really with the traditional means of intellectual property rights laws. Basically.
I have another very specific question from the public, which is the next generation non-surgical neurotechnology N3 program funded by the Defense Advanced Research Projects Agency aims to develop high-performance brain-machine interfaces for able-bodied service members. The first results could accept in 22, and then I have no other text, so I don't know if there is a mistake. Okay. So the other question that I have, what would be the best technology transfer model for the use of artificial intelligence in NATO for the year 2030? You have partially already spoken about this. Perhaps you could develop
the question is about the best
the technology transfer model within
transfer model.
Yes.
So let me take a big picture. That is, I believe the most important part is still the human being. No, and I think that the panel there's a consensus in this. So the key issue is having people in the research centers, in the armed forces, in the Department of Defense, in governments that are able to see problems and apply artificial intelligence, machine learning, big data where it fits. As easy as it is to say, we know from the entire history of military innovation that is challenging for different reasons. Sometimes it's cognitive because some general managers may not accept that the decision is allocated, the control is allocated to a software, or because it goes against their values, reasoning in terms in probabilistic rather than structural deterministic terms is really a way that many people are not used to. So the transfer model I would suggest is that making sure that we promote a societal organizational change in which we are able to exploit the technologies, but we remain in control of the technologies. And as easy as it is to say, is very challenging historically to do. How to proceed? Well, probably having big research funding for university to fund new ways of thinking, funding researchers, promote experimentations are some of the ways to go. We have 3 minutes and a half, so I don't want to talk till the end.
And what will be perhaps the last question that we take is introducing a very important topic, which is AI and new computer quantistic technology. Do you think that the first country that will succeed in obtaining an affordable quantistic computer technology will put at risk the current enough balanced AI war? Anybody wants to jump in on that? Peter.
I can do it very briefly because time is running. It doesn't matter how fast you can do calculations, it matters how smart you make your algorithms. And we can make very smart decisions now in microseconds or milliseconds on single processing cores that can make systems react ultra fast already. So of course, calculation power is important and calculation speed is important, but I do not think that it it will be the cure for all. It's not the silver bullet that can manage everything. It is part of the puzzle, and it has and it will be a game changer, but it will not be able to stand alone. This would be my final comment on that.
Anybody else want to comment on that? No. Yes, Stefan.
Yeah, no, the problem with quantum computing is the ability to break into the code. And so it's about cybersecurity issues, and we know that in AI there might be some security issues. So yes, for me this is a problem.
There are.
Yeah, well, basically, I agree, and I think that those are complementary technological issues. I mean, even now, yeah, the application for quantum computing are basically different from the traditional computers. So it's already difficult to adapt existing algorithm to the quantum version of PC. We're not going to see any soon a quantum computer on our desktop. And adapting artificial intelligence algorithm, which are structured for working on traditional or like computers to quantum, is going to be very difficult. I mean, you can exploit the processing power, but it's not that the point of where the very game changer will be. There will be a separate one.
Thank you very much. So I think we are about to conclude our panel. I really wish to thank the outstanding panelists that have shared their thoughts and views with us. And I always say that the success of a panel is determined by how many questions you stand up with. And this is absolutely the case. So I'm looking forward to other occasions to interacting with you. I really thank you. I think we as governments have a lot of responsibilities and a lot of responses to give. So I take away that from all of you. There's a lot to do, but there are enormous opportunities to do it well. So thank you for shedding a very peaceful and very acute and knowledgeable light on this crucial and important topic. Without further ado, I'd like then to conclude and to leave the floor for Mr. Honorable Pietro Fassino, who is the President of the Foreign Affairs Committee of the Chamber of Deputies of Italy. Thank you once again to all of you. Onorevole?
Thank you. Do you listen me? Yes? Do you listen to me? Yes. Okay. Dear friends, I would first of all like to thank you for inviting me to deliver the concluding remarks to an event so rich in contribution of a high scientific and intellectual level. Days such as yesterday and today demonstrated that the NATO system, is not just a formidable technical and operational framework, it is also a system of thought where ideas are processed and vision are shaped, a veritable think tank for international policy and security. The game is changing. But the commitment and intellectual and moral forces that have always inspired the Alliance remain the same, defending the principle of individual liberty. Of course, we must be able to change and adapt to a constantly changing world, but we must always remain true to ourselves and our ideals. This is the secret of to our 71 years together, the longest strategic alliance in history. As President-elect Joe Biden, to aptly put in his first speech, We lead, not by the example of our power, but by the power of our example. This is all the more true for NATO, which must continue to be a bulwark of freedom and democratic security. But we also know that a contemporary concept of security cannot be the same as it was in 1949 or even in 1989. It has become broader, many-shaped, and multi-layered. It is become globalized, so to speak, as we have appreciated during the remarks delivered these last few days, and now only encompasses environmental, health, and cyber security. As this event window, we are even more convinced and motivated in asking NATO to be at the global forefront of each of these three strategic pillars for 20th century security, in asking to be an exemplary alliance heeding President elected Biden's call. There are still a great many tasks ahead of us, which we can only complete by rediscovering a sense of a shared identity, a common mission. The two shores of the Atlantic must once again share strategic goals and delineate together a world of security and prosperity, while acknowledging and respecting our mutual differences. Legitimate as they may be, we cannot allow the attempts of a new international actor, as China, for example, to take center stage, to take place in violation of fundamental human rights, nor can we allow them to lead to division in the West. This will not be simply game-changing. It will be an altogether dangerous new game. I will now delve deeper into three main topics of this seminar. Health security. Dear friends, the year that is about to end will go down in history as the year of COVID-19. Exactly 100 years have passed since a pandemic had such a deep and drastic impact on human history. Now that we are on the cusp of having a vaccine and thus a medical solution, we must examine the role that policy, and more specifically ill policy, has played in the fight against the pandemic. The conclusion is hard to swallow. I have hinted at earlier, I will reiterate it now. The coronavirus did not bring Western countries together. Instead, it drove them apart. Social distancing between people was followed by a sort of political distancing between countries in the decisions they made and measures they adopted to fight COVID-19. The European Union itself continues to struggle in having a unified approach. The vaccine itself, developed by two companies, one American and one German, is a metaphor of how this crisis can be overcome. It was an alliance between companies, Atlantic companies, that brought back hope and trust to our society, so sorely tried by pandemic. This is a powerful teaching moment that we must cherish. We must be able to turn this tragedy into a vindication of the free democratic world. And this is something NATO can and must help with. We must be able to tell the world that while the virus came from East, the vaccine comes from the West. While the problem comes from the East, the solution comes from the West. Because once again, it is the West, if it remains united and cohesive, that can make the world more secure and more prosperous. Climate security. But there is another challenge to global security that has seen us divided and uncooperative in recent years. I am talking about environmental security and the initiative to fight climate change. We must resume our role as leader in this process. And now is a good time to point out that two of NATO founding members, Italy and the United Kingdom, will be the co-president of COP26 in 2021. Resuming our leadership role in this process means making progress in reducing emissions and promoting clear, renewable energies, and must be underpinned by understanding that a green economy does not emancipate us from the geopolitics of resources. We won't talk about hydroelectric energy and dams, we are also talking about water scarcity and the possible conflicts it might lead to. When we talk about electrical batteries, we are talking about lithium and other precious metals. And we must keep in mind that while conflicts over such resources have not yet exploded, that remain a very realistic scenario for near future. If this innovation in the fight against climate change do not ensure cooperative geopolitics, but instead hint in future conflicts, we cannot help but notice how climate change is already having a significant impact, such as desertification in Africa and the human migration discourses. And I certainly don't need to point out to you the strong link between human migration and the destabilization of entire geographic areas. I will end by saying that I'm personally in favor of establishing a center of excellence of climate and security within NATO, or expanding to remit on the existing center of excellence of energy security to include climate and the environmental security. Third, cybersecurity. I now come to third and final issues discussed during the seminar, cybersecurity and artificial intelligence, and how they can constitute a threat against democratic life in our countries. In recent years, the media has often highlighted the dark and secret side of the world of the communication and social network. Spaces that were created to give maximum visibility can be vulnerable to hidden machination to alter the perspective of their users and to steer their political and electoral choices in a certain direction. The issues of foreign interference is a pressing topic to which the Foreign Affairs Committee of Chamber Deputies, which I am honored to chair, is devoting an ongoing investigation. Indeed, it is increasingly evident that control over telecommunication network, the management of big data, and the investment in quantum computing are ways to predict and thus to determine political decision or popular reaction. Democracies are not the only countries that have this technological ability. Far from it. When facing power's worst constitution, do not emphasize individual liberty and the rule of law, the West must once again prove itself united and cohesive. We must think of cyber deterrence, a new and additional action to pursue global security and stability. We are only just beginning. As you can see, many things await us, unprecedented tax and an unknown road ahead. But this must not scare us. We must only remain on the right side of history, on the side of democracy and freedom. In conclusion, I repeat, becoming more united in order to be less vulnerable, with NATO, to face the challenges of the new century. Thank you very much.
Good evening, ladies and gentlemen. Buonasera a tutti. We are coming to a close of our works. I'm sorry in a way, because I was starting really enjoying this. And of course, as I told you before, the effort of the Foundation has been in these 2 days to focus on the new challenges on international security, because we live in a world which is changing very fast, and we have to be in tune with our times. The Foundation has invested a lot of resources and a lot of work in preparing for this conference, but I am very happy to know and to see that there are many people connected with us, even if it was impossible to be here in presence. And so I thank the 320 people, I think, that are connected with us. Grazie mille. I have also to say that to prepare for these things also increases our learning curve. It increases our knowledge. So it has been very interesting to prepare. In the last 2 months, we've done nothing else than this. So at the end of this, I would like really to thank, first of all, the sponsors, the people who made it possible with their generous contribution to make this event possible. PMI, first, Alvise, Fondazione Compagnia di San Paolo, Nicolò, my old friends in Brussels of Science for Peace and Security, Denise, and everybody else. And of course, I also want to thank the people of Event Boost and the people who and the people from the Foundation, from the director to all the staff, boys and girls who have worked in the past 2 months, I would not say day and night, don't exaggerate, but have worked a lot to have a good event, and I'm very happy of that. And we hope to be back to you with something interesting also next year. Arrivederci a tutti.
Goodbye, everybody.